we will open the floor up to additional questions. Does anybody have a question to answer, or? Yes.
Just a question, Ron. You had on your slide that the simulator needs a champion. Can you talk about how you came to that and how you build that role?
There we go. Okay. What I mean by that is most people, like I was saying, that people imagine simulation as a steady state, as a loop back, as you push start, it shows run, and they don't believe it, basically. So when you have long-established employees that have been operating these processes without this, they come in there and they're like, no, this thing's not going to be real, and they just come in there with a bad attitude. And so when you're trying to build training programs, or you're trying to get more investment for extra modeling, or try to do something like 3D simulation, things that are going to take an investment, it's hard to convince people that, no, this isn't the simulation of the past. This isn't the old hard panels, that just light up lights and stuff. This software is robust, the physical models are real, and we can back it up with historical data. For example, with our simulation, the way we do it, we do basically static model validation, but we do a little bit of dynamics limitedly. So we'll take the simulation, we'll put it in certain load points. And the fidelity is good enough and the math is so set that you can save like initial condition files, but the way you save those is you have to do like an actual startup on the model and run through the process and save as you go. You can go back to those snapshots, but you can't just walk in on a fresh simulation that hasn't been set upon and say, put me here. Because there's so many thousands of values that you can't, it just doesn't work, it just breaks. So convincing people of that realism takes a champion. It takes someone to say, no, look at this. Our models are within 2% almost across the board. We can show less than 2% error at almost any load point for process variables, almost at any point in our model, with very few exceptions. So showing people that and having someone there to say, no, this isn't a loopback. This isn't something that this is the real deal. And this is the, and that's essentially what I mean by that. So.
All right, the next question.
There's of course real scenarios that happen when operators make mistakes. Do you feed them in scenarios in your simulation so that these are particularly trained and avoided in the future?
Absolutely, and that's part of the new program that we've implemented where we rotate our operators through. The idea there is any scenario that we see in the real world is actually fairly easy to replicate if we know the root cause on the simulation. We can go to that flow sheet, that part of the system. We can say, okay, maybe it was operator error that caused it. Those are the easiest ones, because then it's just setting the model up in that position and just making them try again. But when you have equipment failure where the operator could have been more proficient and possibly could have saved it or could have prevented a load loss or a unit trip, we do replicate those situations. If it's a really complicated one, there is, like on ours, there's a scripting language that we can actually program to set the model up where we need it to be. And you can always go back to it and just load it at a different time. For most of them, what I find, it's as simple as, okay, this day we were sitting there at 300 megawatts, this mill tripped, and they lost a third of their fuel flow. They could have saved it, but they didn't. So all we have to do is we'll go to 300 megawatts, we have an IC saved somewhere around there, and we'll just reach up and trip the mill with malfunctions that we have built in to the models.
Rick mentioned maintaining the models. So sustaining the models, how's that been for you? Has it been doable?
As far as sustaining the models is really not an issue with ours. Once they're set, they're set. You have configurable parameters that are all configured. It's all based on historical data and design data for the plant in question. So once that's set, it's there. It's not a matter of having to go in and do any kind of regular maintenance. What happens is we're in there and we realize, we're like, well, wait a minute, that didn't act right. Why did that pressure swing, or why did this temperature drop off? So maybe the metal mat doesn't have enough mass. The temperature's dropping too fast. Things like that is where you have the opportunity to go in and tune the model or add elements to make it more and more realistic as you go along. And then also what goes along with that is new systems. With us continuously adding new environmental controls injecting new chemicals into our boilers. We want to see the effect and the impact that's going to have, but we also want to train our operators on how to operate this stuff. So adding those things is probably the biggest bulk of the modeling work that we end up doing, is building those things, which actually also gives us the extra benefit of testing controls and actually developing controls for a new system. Because we may have an engineering model for a piece of equipment, but for the process controls, usually need a lot of work to try to make them work in the real world. So the simulation gets us pretty close every time.
So I want to interject quickly just because I want to get Joe involved in this discussion, right? So Joe, the question for you is, Ron mentioned that he found 144 errors they missed in FAT, right? That's a lot of errors. Obviously, operator training simulators can be very effective as a mechanism of testing. Do you see a trend, or have you often used operator training simulators or some type of simulation in FATs when you're engineering the project before it's sent to the plant?
So yeah, we've seen for all the safety instrumented systems, all the control logic, typically that all has to be checked out. All that logic has to be checked out before startup or during FAT. So we developed specific tools as part of the same engines and software that Ron uses at SRP to do that entire and automate that entire safety instrumented system checkout for you. And we found that that saves people a lot of time in their turnarounds, saves them a lot of pain from experiencing delays in startup because of all these control errors. So yes, to answer your question quite simply, we found that that is a tremendous value that our customers are getting, and we have a lot of feedback that's very positive reviews on our control system checkout.
I can add a little to that. For the reasons why we see that, from what we saw, because we went through a factory acceptance test, which was a loopback model, essentially. We would set an output, the input would show on. You would show pressure on the line enough to maintain the logic. What you don't see are dynamics. You don't see that when you push start, sometimes, a motor won't show running for 2 or 3 seconds. It might take 10, 15 minutes for the line to pressurize, and for the temperature to come up, you may be warming for hours. So you don't see that kind of dynamics on a steady state, any kind of simulation or emulation that you're doing. When you add the dynamics, that's when it starts coming home. You're like, uh-oh, I didn't think about the fact that this valve takes 10 seconds to stroke open, which is going to, decrease the time for pressurization and temperature and all that. So.
Any other questions out there? I have more. Did you find that when you ran your simulations that you were able to handle a very common problem in a lot of facilities is alarm overload when things go wrong, and it's very, very, very common that deployed control systems set way too many alarms and you get alarm avalanches during abnormal situations. During your training simulators, did you find that you were able to rationalize some of your alarms as part of those errors?
Absolutely. What we found over the years is no control system vendor wants you to call them and say, I just caused $5 million of equipment damage because it didn't alarm. So they alarm everything. I mean, every alarm's active, the ranges are set reasonably, but you have so many alarms that you have to find a way, otherwise you're going to be the #1 enemy in operations. Every time you walk in the control room, they're going to bombard you, call you names, throw things, whatever. So the great thing about that, and especially with having the operators go through the training before we actually commissioned the new DCS and went into that original startup, was we're going through these startup shutdowns, excursions. We were getting operator buy-in at the same time and getting their feedback. So we could say, they would get an alarm flood event. We had taken care of most of that by the time we started running them through the training. But as we went along through the training, we're like, okay, well maybe they'll look at a description and they're like, well, what the hell does that mean? I don't know. What are those acronyms? Because you're limited in how much text you're going to display in an alarm field. So we were like, okay, we would get their impact on, well, what could I say that would make it make sense to you? How can I get you to where you need to be quicker to take action? So absolutely, that's been a great benefit for us.
You know, I mentioned in my presentation a lot about immersive simulation because I wanted to cover the whole space of simulation. Now, obviously, you have some experience in gaming engines and things. You're the natural person for extending your simulation capability in the immersive direction. What would you think would be the incremental benefit? Would you train maintenance people? Would your operator training expand from 120 hours to more? What would immersive training do for your facility?
It would be multifold. There's one thing for maintenance, and I've seen some really cool 3D simulations for doing maintenance and rebuilds on motors and gearboxes and this and that you can actually go through with maintenance. So that's one part of it. For us in operations, when you're going through a startup, for example, you've got the guy sitting there at the board, but not every valve out there we have an actuator on. You've got manual valves that you have to operate. There are things that have to be done in the field to successfully operate any type of plant, whether it's a process plant or a power plant or whatever. So what the 3D simulation would essentially do for us is to be able to train the field operators at the same time, which gives us a multi-fold benefit. For one, you're teaching field operators, and visually they're actually seeing and they're walking their little avatar up and turning valves and that kind of stuff. So they're actually learning where things are at in the plant, how they need to do it, but at the same time you're teaching them communication patterns to communicate to the control room and the field operator. And so our control trainees, we can teach them how to better and more effectively communicate with the field people to get them to do what you need them to do.
Question, I presume, it's an assumption that many times your simulation environment is idle. Is there potential to share that with other plans that you have out there, or think about having that deployed at the vendor and running your simulations there for maybe the 4 or 6 weeks that you need it through the year?
Yes, there is actually a way to do that. And I can let Joe kind of answer this. They actually have a technology solution for a cloud-based simulation system. For us at our plant, I was kind of, I don't know, I can't think of a better word, but Nazi-ish about hooking our simulation into the network. And a lot of that was more for cybersecurity reasons, not necessarily for the process data and the modeling side of it, but more the control side. We have our turbine safety controls, our burner management system, all of our DCS controls there. We don't really want to open that up to a path to the internet type idea. There are actually newer technologies. I know SimSci has one. I think they call it SimCentral or something like that. It's actually cloud-based that you can share. The idea is more an enterprise level to share process models throughout the organization. So, but we're not doing that currently.
So from a SimSci perspective, one of the things we can do is, because OTS is so time intensive and requires a lot of maintenance on the end user, what we can do is we can offload that and put it in the cloud. And it's similar to software as a service. We call it training as a service. And we can host your entire operator training simulator, your whole setup. We can also make sure that we do the upgrades for you on the back end. So whenever the software is upgraded, we can update that in the cloud for you. And we can also work with you on a services thing. If you're changing your DCS system or you're making small changes to what you inject into the feed water, we can update the model for you. But we do have that ability to host everything in the cloud for you, so you're not doing it all on premise.
I have a similar question, I guess for Rick and Joe. Are you seeing universities and trade schools starting to use immersion training and simulators? And for Ron, would you consider sharing some of your simulations with universities?
So last year we had Professor Richard Turton from the University of West Virginia present up here, similar. And he presented solely on how the University of West Virginia is working with the U.S. Department of Energy, and they've created not only an operator training simulation, but they also did the next layer, which is the immersive. We call it iSim at SimSci. And they have this entire facility at the University of West Virginia in Morgantown to train operators on how to use IGCC, integrated coal gasification combined cycle, the entire process. And they're working directly with the DOE. They worked with Invensys or Schneider Electric to develop that and put that out there. So now they not only train operators as they're going out into the workforce, but Professor Turton has brought that into his undergraduate and graduate curriculum at University of West Virginia in the chemical engineering program. So yes, it has been, and we have seen other academic institutions use iSim and operator training within their usually graduate studies.
And for us, we have used it limitedly with like our interns. We'll get the guys come up for the summer. A couple of summers ago, I had an engineering intern there. He was fascinated by simulation, and particularly he was more fascinated in AI, and we actually have a combustion optimization system that we use that uses lower level AI that I did integrate with the simulation. So he got to do some work there and kind of get a feel for the models. I don't think we do a lot of work with the local community college at that level for some industrial maintenance programs and operator type training and certificates and actual 2-year degrees. It's not something that we've done yet, but it's something that we're open to.
Actually, just to finish up on this question, I've certainly seen in the past a number of control system vendors have donated hardware to chemical engineering departments and other engineering departments, in part to run some of their equipment. But you definitely bring up a good point, especially where you can put a lot of these things as cloud-based solution. It would be very easy and inexpensive to get those next generation of operators pre-trained and pre-oriented to your product. So I guess from ARC's point of view, I would encourage those vendors that can provide that to work with universities in that regard, because there will be some support costs for you to keep those guys up and running, and obviously you have to have a champion at the university site that's able to maintain the installation and understand what it is, but a very potentially useful technology going forward in the cloud.
So just one more thing to that. So when Ron presented his OTS, it's very specific to SRP. I mean, very process specific, and he spent a lot of time tailoring it so that it's high fidelity model of his process. We also can do generic simulators. So they're just industry standard simulators, operator training simulators. So we partnered with a couple institutions. One of is Houston Community College, and their only goal is to do the operator training to get them through the 2-year certificate program so they can go out and work in industry. So we've worked with them to generate generic simulators so they can train their operators to go out, get their certificate, and become members of the workforce.
Ron, just to follow up a little bit on the training side of things, are you seeing any differentiation between an experienced operator using a simulation versus some of these younger generation coming into it?
As far as, I kind of mentioned that, for me, early on when we were first starting, the operator, from that one slide that I had, it showed in 2010 and 2011, our average years of experience was up over 15 years. And that's actually in a control room position. So they have actually made it up through the ranks. A lot of those guys have been there 25, 30 years. So that was the first group that went through simulation training. My measure of performance was getting their feedback, like, does it feel real? And it was funny because you could get them going. They're sitting there, and at first, everybody doubts it, and that's it, back to that champion thing, right? At first they're like, I've been to these simulations before, thinking. And then you sit there and you start throwing some stuff at them, and they're like, holy crap, this, and then you see them sweating, they're like, oh no, they're trying to save it. It becomes of course, a matter of pride for them, right, to be able to perform. But also, I got extremely good feedback on the realism of it. And they also pointed out a lot of things that could be better, and that's what we did, so we did improve them as we went along. So that was like a twofold benefit for all of us, I think.
Maybe adding to that question, is that motivation enough for the operators to not fail, or would you see a benefit in a gamification approach that like in a computer game, award levels if you mastered this certain scenario or so? Have you looked into that?
I think so. That was I didn't talk about it a lot, but that training performance monitor that we added does a 0 to 100% score. And we just barely programmed that and built those grading scenarios. So I've only had a few operators to test on so far. And the operations culture is very competitive between operators. So I can imagine, I've already heard people talking, like, you know, yeah, you're gonna suck and I'm gonna get better. So that's kind of already started. So yeah, I think so. I think we could see that impact out of actually having that number score, you know, that kind of gauges them.
I want to just add one thing to that. In my recent operator collaboration survey, a number of people warned me against trying to publish out on the open knowledge of which operator is best, second, and third, all right? They said that, yeah, operators are very competitive, almost like a prison environment. They're gonna find a way to sabotage the operator above them so that they can get ahead. So just want to make sure it doesn't get too competitive, all right?
Well, absolutely. And, you know, it's up to the operators if they want to share their scores, but it's not something that we would like put on a website or something to get them. We want them to be a team. We don't want them to fight each other. But as a measure to just improve their immersion into the simulation, absolutely. I think that's more the idea.
I'd just like to make a comment. So most of the discussion here is about process control environment. I work in a mining environment, and Rick, many of your the drivers, and you talk about ROI, would apply for mining equipment or construction equipment, where you have today, basically we take senior operators and they put new people with them, and you have a tendency just to perpetuate pet ways of doing things, and a lot of times maybe not the best practices. So I can see this type of thing, it really has application well beyond just the process control environment as well too. So, very good discussion. I appreciate all these comments that you guys are sharing with us.
So, yeah, great. I saw a tremendous amount of technology developed by companies like Caterpillar Tractor, and you can imagine the number of accidents that occur with cranes, hoists, bulldozers, and various other kinds of equipment. And they have spent a tremendous amount of time and effort to train their equipment operators, have some very interesting immersive simulators as well that you wouldn't see in the normal process industry.
So I think in the mining industry, one of the additional problems that you have, and correct me if I'm wrong, is your operators, once they're trained, they don't stay on the job too long. So I think getting them up as efficiently and effectively as possible with an operator training simulator is important, because you want to get them up to speed, so if they only stay 2 years or 3 years, they're actually effective for a majority of that time. So I know from a SimSci perspective, we do work on the process industries, but we also are big in mining for operator training. So if you'd like to learn more about that, we can get together after this.
And I actually know an engineer that built the same type of simulation that we have for a mine in Western Australia somewhere. So I could get you his contact too.